Hi everyone, this video is for section 6.3 covering inverse trig functions. This video is going to be a little bit shorter than some of the other ones. We're just going to look at a couple of light inverse trig functions here. So the first one that we're going to look at is the inverse sine of negative root 2 over 2. When working with the inverse sine function, remember that the range is restricted on that function between negative pi halves to pi halves inclusive, hence the reason why I have brackets instead of parentheses around my restriction that I've noted for myself in black. So if we recall, that means that we would not look for our solutions in the second or third quadrant. Also notice that we are working with a negative root 2 over 2. So if you think back to your unit circle, that means that we would not use quadrant 1 either, because all those outputs for sine are positive. So that means that we are going to work exclusively in the fourth quadrant. Okay. I still tend to use the first quadrant to help me figure some stuff out though. So for example, I know that if I worked with either the sine of, if you're working with degrees, it would be 45 degrees, or if I did the sine of pi over 4, that would give me a positive root 2 over 2. So that means that if I came over here, I could say the same thing. Well, the sine of negative 45 degrees or the sine of negative pi fourths should give me a negative root 2 over 2. Okay, so our solution in this case is going to be negative pi fourths. I'm choosing negative pi fourths 1 because my restrictions were presented to me in radians, so I wanted to try to keep my answer in radians. 2, I'm using negative pi over 4 as opposed to its positive angle counterpart because, again, I want it to stay within the restrictions that I've set. Okay. So let's move on to the second example. So here we have the inverse cosine of negative root 3 over 2. And again, its range restriction is between 0 and pi inclusive. So this means that I'm not going to be working with the third quadrant or the fourth quadrant. I also note that all of my values from the first quadrant would be positive. So this tells me right off the bat that I am working in the second quadrant. However, I do use the first quadrant to help me out. I recall that an angle measure of 30 degrees, so the cosine of 30 degrees, or in other words, the cosine of pi sixth, if I'm using radians, is going to give me a positive root 3 over 2. So I can use this as a reference angle. So if I were to come over here, I would just want to find out what this angle measurement is. So going from here to here. So quickly I can do that by saying, well, I could do pi minus pi sixth. This would give me 6 pi over 6 minus pi sixth, or 5 pi sixth. If you don't have your unit circle readily available, or if you don't have that kind of figured out in your head right at this moment. So that means that the cosine of 5 pi 6 is going to give me that negative root 3 over 2. So my solution then in this case is going to be 5 pi 6th.